Welcome to the session. Greeting of the day. In the last class, we are on the discussions of various types of sensors. In those types of sensors, we have previously discussed about strain gauge measurements, and then later we have discussed about capacitive sensors, photoelectric sensors. Those things we are on the discussions. There, in the last end, we have done photoelectric sensors. In this, what we have seen, photoelectric sensor, a very simple method, a light source we are using. A light source, how a photosensitive device can be used to detect the presence of an object by breaking the beam of light. How? You see the image, very simple. A light LED, we are simply using the LED lights. Right? We are sending a light source and it is calibrated. We are kept. No object is disturbed. As like a door opening, closing. Right? So, when a person comes here, or it is blocking the rays, a light source, it detects photo detector. Here also we have emitter. This is the emitter. This is the receiver. Right? Acts like the emitter receiver, receives the signal and it gives the object is there, the presence, the position we can able to find. The positions we can able to find. Right? What are the other options we can do here? So LED, and then we have a photo detector. So what happens? It goes here and falls on the object, and there we have one side it is LED, one side it is photo detector. But here the other options what we have, one side LED and other side it is reflected back to the detector again. So likewise a simple method we can follow. So this breaking of light or infrared radiation is falling on such a device or by detecting the light reflected back by the object. Right? Is a photoelectric sensor consists of primarily an emitter or a receiver. An emitter, what it contains, you see, what it contains here we have. This will be the emitter, and then the object stops, comes interacted here, and then here we have the receiver. So I am mentioning as simply in terms of emitter and then the receiver. Right? It emits light, it processes through in this direction, right? And then when the object, I am writing this, when the object is obstacled, what happens? It returns back this signals to the receiver back again. So what happens here? When an emitted light is interrupted or reflected by the sensing object, it changes the amount of light that arrives at the receiver. So it changes, the sensing object changes or interrupts the light sensations. Those signals will be converted to the electrical formats that we see. See, the receiver detects the change and converts into the electrical formats that I am writing here. See, right? The receiver detects this change and converts into an electrical output. Okay, that will be clear. This light source for the majority of photoelectric sensors is infrared or otherwise the visible light. Which one? Maybe in the red color, maybe or in the green color, maybe or in the blue color also. Which for our easy understanding, we have seen the laser lights generally in red. We have seen this laser lights, visual lights generally in red, maybe in the green, maybe in the blue also. Right? That is how we have seen about this photoelectric sensors. So I would like to play a video here for these concerns. So let me play a video here. See, it is the object of sensing element where we can able to see the photoelectric sensors ascending the light source and it receives the other end when the object is obstacled. Therefore, it is a simple video animated which shows you how this happens. What are the advantages we have here? You can able to sense from 50 meters to the 550 mm to the 500 mm also. For example, I am maybe a whiteboard, you can keep, it is able to detect for a long distance of 1500 mm also. If the object is inclined also, it is possible to detect. In any spot needed to obstacle those objects, that's it. It may be inclined, it may be a straight, it may be a white, it may be black, whatever it is. Right? So see there it is marked as a 700 mm it is checking, and also 800 mm, 1500 mm. Is every object, maybe a lengthy object or a short object, it is detecting. That we understand here. See, one object, a blue square object, is a large size, and another object is a small size. Therefore, any object of size can be detected. Right. So this is how we understand. So now I am showing this video for maybe what is the brightness level, maybe a dim or maybe a more whiter. It is not depend upon the colors, maybe a black, maybe any colors. It should be some object to cross those light sources. That's it. We can able to identify. We can able to check those things. See, animated a white object is crossing, a laser red color laser is checking out, and a white object is crossing, the red color light sources photoelectric sensor is checking out. So in such a way it is possible to make those cases. So that is enough for our animations. So each and every industries are using those photoelectric sensors for checking, crossing, whether the object moves. The same sensors can be utilized for us for the door open, closing, for theft identifications, whether anyone is crossing there or not at ideal time, at home, whether dogs coming in, any examples. The thing you should understand is the object should cross, it detects and gives out. That's it. Okay. Right. So, let's see the advantages we have to see. Number one, it is a long sensing distance. A long sensing distance, we have covered it, we have mentioned this as from 50 or 20 mm to 1500 mm. For example, we have given a long sensing. Then it's virtually no sensing object restrictions, maybe a glass, maybe a plastic, maybe a wood, whatever it is. That is what we have told, a small object or white color or black color, inclined portion, whatever it is. Okay, very fast response timing, in immediate, it reflects and comes and receives. There's nothing conversions taking long time coming back. No. Okay. Then high resolutions, whatever it is, in immediate, all the parts are reflected. No contact sensing. We should not touch or force, pressure, nothing else is there. It's just a laser light or visual infrared light. It's passing through and reflecting back. Okay, so easy adjustments can be done. Now we have, see, the remaining part of the next sensors I am moving from here. It's a velocity and motion sensor. Up to now we have covered the displacement, position sensors, the Hall effect sensors, potentiometric sensors, capacitive sensors, all depend upon the displacement. Here we are talking about the rate of change of displacement. There we are talking about the movement or change. Here we are going to talk about the motion, right? The velocity, rate of change of displacement. Right? The velocity sensors that can be used to monitor the linear and the angular velocity, and detect those motions. Right? So the velocity sensors is used going to detect both linear both linear and the angular also. Right? We understand this. We go ahead. See, it consists of a wheel. It consists of a wheel of a ferromagnetic material which is attached to the rotating shaft. In this picture, it is showing clearly here. Right? A material, ferromagnetic material, which is attached to the rotating shaft. We are going to count those shaft rotation, the angular displacement, angular speed, angular velocity we are going to found by using this magnetic material formation of this electric field. So picking up a coil, wounding in a permanent magnet, we have done now. Right? Next, what we can do here, as a wheel rotates, as this wheel rotates, the teeth moves here and there with respect to the coil. The coil we have attached here, and then the ferromagnetic material coil has been wounded throughout those things, and from the wounding, the wheel is here and the wheel is attached. When the wheel is rotated, due to these electrical connections, the EMF will be generated here. This EMF generation is calibrated. EMF generation is calibrated. When there is the disturbance between this, due to this wheel rotation, what happens there? There will be a change of voltages, change of electrical circuits, change of EMF happens there. The calibrated EMF will change. Therefore, this change we are going to find there. So we see that as the wheel rotates, the teeth move past the coil. So what happens? The air gap between the coil and the ferromagnetic material changes. The air gap between the coil and the material changes. Therefore, what happens there? Therefore, we have a magnetic circuit with the air gap which periodically changes here and there, This changes we are going to measure. Thus, the flux linked up by the pickup coil changes. The resulting cycle changes in the flux produces an alternating EMF depending upon these wheels, toothed wheels. When the tooth is not there, that is calibrated portion we consider. When the toothed wheel changes, what happens there? This changes the EMF. Those is connected to the circuit and we measure those things. Okay? See, an alternating EMF is generated. The alternating EMF generated is a measure of angular displacement. From the picture you can see there are one rotor is given here, one rotor is given there, and the magnetic coil, and this magnetic coil is surrounded by the electrical circuits to the electrical counter. It means the signal conditioner we are connected there. So what happens there? So this change in EMF will be converted into the electrical signals for our understanding, which tells this is the speed which rotates of the shaft. So easily we can able to measure the rotation into the electrical format easily through the methodology of tachogenerators. So that is what given. A pulse shaping signal conditioner is used to transform the output into the number of pulses which can be counted by the counter. Counted we have those counter counts these pulses. The pulses will be created. The pulses will be created as the tooth comes there. If there is no tooth, there is a long range of signals. If the tooth crossing comes, there will be change in EMF that we are going to measure. Right? We understand this. See, I would like to add a video link here for our better understanding. We have a rotor, a wheel component into one end, and an alignment of the other component at the other end. It means the tachogenerator other end. When the wheel has been rotating here. The toothed wheel generally first there is a calibration setup between this tachogenerator, a flux leakage, and the wheel and the tooth at a null position. When this wheel is rotating, there is a disturbance in the fluxes, the gap, there is a disturbance in the flux and the EMF produced in the field. This flux will be disturbed. This disturbance gives a pulse value. This pulse value we can able to measure. If the flux leakage passes through the non-tooth location, it will be in the null position, or it will be calibrated position, or it will be high. When it is crossing through the tooth positions, what happens? When it is crossing through the tooth positions, there is a change in the fluxes. It will be micro level, a change in the fluxes. These changes are converted into the pulse format for the usage, and this pulse can be utilized for understanding of this measurement of speed, which can be connected to the voltmeter, and it will convert into the electrical format, which we can use for the understanding of the speed measurement of the tachogenerator. Right. See, next sensor we are going to discuss about the pyroelectric sensor. It works on the principles of pyroelectricity. So crystals material are made with lithium generates a charged particles in response to the heat flow. A crystal materials like lithium generates a charge by response to the heat flow. In presence of an electric field, when the crystals or materials are heated, the electrical poles are lined up as shown in the picture. Before, in the first picture, we can see it is randomly organized but not organized. In the second picture, when on the electric field, when the heat has been induced, these poles has been lined up. Okay, we know this. So now what we can do, this lining up is known as this polarization process. Now the heat source is removed from those positions, but this lineup are not disturbed. On cooling of the material retains its polarization. It means the poles which are lined up or in the lineup itself not changed. Okay. Now what happens? You see, in absence of this electric field, when this polarized material is subjected to the infrared radiations, or polarized or reduced, it means the polarized material, we have removed the heat, polarization is there, but when again the heat is applied, the polarization reduces. Therefore, this phenomenon, this change in polarization, this change in properties are measured in terms of movement of an object. In this pyroelectric sensor, it comprises of a thick element of a polarized material coated with a thin film of electrodes of lithium tantalite on the opposite faces. We have kept a pyroelectric material at the center, and the force is applied. See, pyroelectric sensor is here, and the force is applied at the other. Force means the thermal forces in the thermal temperatures are applied over the other end. And if this calibrated polarized measurement, if it is calibrated, it changes due to this thermal energy. These calibrations will send the signals, where the sending signals will be checked, and it can be again electric field be applied, or it can be used for understanding that the changes are occurred. Likewise, we can able to understand. See, in this, initially the electrodes are in electrical equilibrium that we know. Electrical equilibrium that we know with the polarized material. On incident of heat, it means the first picture, what it shows, it is in equilibrium condition. The positive and negative charge particles are in equilibrium. When the heat source is applied, the second one, when the heat source is applied, the second one indicates the variation in the positive and negative numbers. Therefore, what happens? This change has to be measured. So what happens? This material heated up. When the material is heated up and reduces its polarization, this leads to the change in imbalance of this charges. These charges are measured and it want to be done for the next one. To balance this disequilibrium, what we are doing, the measurement circuits supply the charges. To balance this equilibrium, the measurement circuit supply the charges which are calibrated against the detection of the human object. Or it is the movement that we have identified. Now I would like to give a small image here. See, this image is, we can clarify that a sensor, a pyroelectric sensor, we have kept aside those side, and when any animals or a human being are crossing, it refers a human being is a heated object. When these heated objects are any minute micro temperature also considered here. So when it is crossed there, this heat reflects the polarization effort. Therefore, what happens there? The change in polarization happens. Those signals are detected. So what are the applications we can go here? So object movement we can able to find. Human movements or animal movements. Any thermal as looks as a thermal detector, we can use this. So with respect to this, the remaining parts, we'll see you in the next session. Thank you.